Our next example showcases Boyle's law, which relates our pressure to volume. So in this example, it says a gas occupying a 2-liter flask at 760 millimeters of mercury is allowed to expand to a volume of 6,000 milliliters. Calculate the final pressure in atmosphere. So what we're trying to relate here are pressure and volume, and we do that with Boyle's law, which says P1 times V1 equals P2 times P2. So what are our variables here? P1 is our first pressure, which is 760 millimeters of mercury. Now, we need to get that into atmosphere, and we do that using dimensional analysis. Dimensional analysis tells us that in 1 atmosphere, there are 760 millimeters of mercury. If you're not sure where that relationship came from, it came from the table in chapter 8.1. Now, millimeters of mercury will cancel with millimeters of mercury, and I have 1 atmosphere. Okay, next I need my first volume, which happens to be the 2.0 liters. P2 is actually what I'm solving for. They want me to calculate the final pressure. So that means I must know what the final volume is. In fact, it is 6,000 milliliters. Now the units here don't match. How do I go from milliliters to liters? I can say that for every 1 liter, there are 1,000 milliliters. And we had talked about that when we were looking at unit prefixes back in chapter 1. So milliliters cancels with milliliters, leaving me with 6 liters. Now what I can do is plug in all the values that I know. So P1 is 1 atmosphere, V1 is 2 liters, P2 is what I'm solving for, V2 is 6 liters. So if I divide both sides by 6, I find out that P2 is equal to 0.3 atmosphere.